Hi, everyone. Welcome to Saito for Dummies. So Saito is a blockchain that's meant to be for providing infrastructure in the Web3 world. As part of this presentation, I'm going to be explaining how the blockchain works, why it exists, what it does, and also why I think it's a very interesting project too. So first and foremost, my name's Arthur Iwanazan. I have an educational background in computer science, and I've been working in the software development industry for a couple of years. So I'm also a blockchain enthusiast, and I'm very passionate about learning. So I love learning about new technologies and blockchain too, and that's kind of what brought me into Saito too. So hopefully with this presentation, you will also learn something about blockchain yourselves as well. So first thing, what is a blockchain? So I kind of view blockchain as this immutable append-only distributed ledger. And this ledger it's distributed. So you have many people sort of sharing the exact same copy of the ledger. And they're all sort of communicating with each other to ensure that their ledger is synchronized. And this ledger is also append only, meaning you can only add data to it. You can only add blocks to the ledger, and they're chained together, hence the name blockchain. And once they're chained together, or once a block is chained to something in the past, the idea is that you can't modify anything that was in one of the previous blocks, because then that would ruin the entire blockchain and the trail of hashes. So ultimately, the purpose of a blockchain, I kind of see it as a mechanism that's used to maintain this universal state. And it really depends on what blockchain we're talking about with what a state is. But if we look at the Bitcoin network, for example, the Bitcoin state is ultimately a state that indicates who has how much Bitcoin at a given moment. And when people are sending transactions in the Bitcoin network, they're getting posted inside of new blocks. And then those transactions are going to be modifying the state. So after new transactions happen, there's continuous updates being done to people's balances. It also works in a similar sense with different blockchains too, when we're talking about Ethereum and Saito for that matter. So now, normally blockchains, with a blockchain, you wouldn't actually be able to delete information off of it. But the reason I have normally highlighted in orange there is because Saito has it takes a sort of different approach to this. Data can actually fall off of the Saito blockchain, but I'll clarify on why that happens in the near future. So blockchains are enabled by peer-to-peer networks where participants or nodes, they of course have their own local copies of this ledger. And like I said before, they're sharing data and transactions with each other to have that synchronicity amongst themselves. So when we're talking about blockchains, every blockchain sort of has a different sort of set of rules that they follow. But the idea is that the reason why blockchains are seen as valuable is because you have a collection of people or participants who all agree upon the same rules. And it sort of brings in this notion of there being value because of the number of people that are sort of following it. Similar to how you could say that a fiat currency has value because of the number of people within a country that are that agreed that fiat currency has value. Now, one more thing with blockchain technology is that since it is distributed, there is no single source of truth. The idea is that there should be thousands of the same source of truth, and that also makes it something that is difficult to destroy. So who are the actors in a blockchain? Generally, when I think of blockchain, I think of three different types of actors or three different types of participants. And the first type of participant is someone like you or me, who might not necessarily run a node and actually participate in the maintaining of the infrastructure of the chain itself. So as an end user, what you'd be doing is you'd actually be interacting with applications that could be built on top of the blockchain itself. And and then you actually create transactions and route transactions over to the blocks that compose that blockchain as a way of interacting with with that blockchain. Now, most of us, I'm sure, use wallets like MetaMask, but we don't actually run those nodes ourselves. And we are actually dependent on node providers to do some of that work for us. Because in order to interact with the blockchain, you actually have to have a whole copy of the chain of itself, or at least the state of the blockchain. Yeah. So moving onwards to the next different type of participant, we have nodes. And what a node's job is to do is to essentially service users and sort of act as their gateway to the blockchain itself. So nodes are also responsible for storing the blockchain, storing the state, like I already said, and they also share transactions that come from the users amongst themselves. And while they are sharing these transactions, they validate the transactions too. And the idea is that if I were to send an invalid transaction to a node, then that node would realize it's invalid and shoot it down before it shares it with any of the other participants. And an example of an invalid transaction would be if I were to spend money that I don't have. I would be sending Bitcoin to my friend, but I don't actually have that amount of Bitcoin in my wallet. One other use case for nodes is that they're responsible for sharing copies of the blockchain with each other. So with a blockchain, there's really strength in numbers. You want to have more nodes, more people who can validate those transactions and act as sort of gateways for the network. And in order for the network to grow, you need to have new nodes entering who have their own copies of the blockchain. So these nodes are actually sharing their own copies of the blockchain with each other. And the idea is that if I set up a node, then I should be able to sort of depend upon another node who will provide me with their copy of the blockchain, just so I can sort of contribute towards the infrastructure, just like they have in the past. Now, the third different type of actor that we have inside of blockchains are miners or stakers. Depends on which blockchain we're talking about, what the consensus mechanism looks like. With proof of work, we're talking about miners, and with proof of stake, we have stakers. But ultimately, they really do perform the exact same task. And what miners or stakers are is they are very specialized nodes that spend most of their energy actually writing blocks and writing to that blockchain and sharing those blocks that they found with the other nodes and participants in the network. So a miner or a staker would probably spend a little bit less energy towards sharing transactions with each other. These are very specialized machines if we're talking about proof of stake, and they're ultimately going to spend way more energy just generating value for themselves by writing to that blockchain. So when we're talking about incentives in a typical blockchain, a blockchain that is open and permissionless, it needs to support itself. And most of the time, these blockchains support themselves by providing some sort of token or coin that provides incentive for that participation, for the providing or provisioning of infrastructure. So if I run a Bitcoin miner, then by posting transactions on the blockchain, I get incentivized with my own Bitcoin too. Now, typically with proof of stake and proof of work blockchains, and with most of the blockchains that I've seen, miners and stakers are the only participants who do get paid, and nobody else gets paid, unfortunately. So when we're talking about nodes, those people who are sharing and validating transactions before they get included inside of blocks, a lot of that work that's necessary is actually, it's not incentivized, or at least it doesn't have any sort of monetary value sort of assigned to it. And if I were to bring this closer to a real world example, I would sort of compare this to a really crappy coal mine, where the only way of turning a profit or the only way of making money is by mining and extracting coal from earth. And none of the other activities that are required to keep this coal mine operational are incentivized. So there's no way to, so people who are providing the pickaxes won't be making money. People who are distributing the coal won't be making any money. Or even those who are like providing the lighting or the electricity that's required to keep this mine running, they're not going to be making any money. It's making money themselves. So that's kind of a problem. And before I kind of go further along this presentation, I want to highlight one thing that I think is really important, and that is the notion that transactions have value in themselves. So miners need transactions to include in their blocks, which they post on the blockchain. And when they post data on the blockchain or blocks on the blockchain, they make money. So they need transactions in order to turn a profit. And so that must mean that transactions should have some sort of value in of themselves too. Yet we are in these blockchains like Bitcoin and Ethereum. The idea is that we should be sort of sharing these transactions with each other in an open sense. Yet it is completely possible that we won't see that because it's actually because the incentive is to actually keep the transactions for yourself so you can benefit from that. So I think it is completely possible to see transaction hoarding in the near future if we haven't seen that already. So if I were to tie this closer to a real world analogy, I would sort of compare it to the situation where we have a wooden chair shortage in the world. So if I manufacture and sell chairs, then I shouldn't really expect to receive the wood that's used to make those chairs for free. And similarly, if I own a forest and I cut down trees in order to get wood, then I shouldn't really be giving out that wood for to anyone for free either, right? An arrangement that you're much more likely to see would be where I would be sort of exclusively, or I would be selling my wood to people who are willing to pay me for it. And another alternative is for me to possibly start my own manufacturing company and exclusively share my wood with that one company for some benefit. Yeah. So either way, like with this particular situation, I'm actually incentivized to act in my own self-interest. So I can hoard wood myself or very selectively choose who to share my wood with, just so we can sort of benefit each other. There's a deal that's being done on the side that isn't actually good for the greater good of the community. And that's actually kind of one issue that we have in a lot of these blockchains where the incentives aren't exactly aligned. So when we're talking about blockchains like Ethereum, a typical maximalist argument that you might hear is that miners and stakers would actually provide the infrastructure themselves, that unpaid infrastructure themselves, because they won't get paid otherwise, right? So at first, this sounds like a total valid argument because if there's no nodes to make up the network, then there's not going to be any sort of, there's not going to be a value in numbers, and there's not going to be any sort of transactions to make money off of in the first place, right? So it does make sense, yet it wouldn't work. And that's because public choice theory in economics would sort of dictate otherwise. And this public choice theory says that if the personal and communal incentives aren't aligned, then people will actually choose to act in their own self-interest rather than what is for the greater good. So this actually sort of this could potentially introduce this idea of or this scenario of a free riding problem, where miners might sort of expect other miners to provide that infrastructure for them just so they don't have to, right? So you do all that, you do the work of providing the nodes so I don't have to, and I could still spend most of my energy focused on mining. And this is equivalent to a really crappy school project where maybe maybe I do all of the work, but my teammates won't do anything. They kind of expect me to do all of the work for them. Now, also, in a similar sense, since transactions have value, some people have sort of realized that even though, despite the fact that they're being shared in an open manner, or despite the fact that they should be shared in an open sense, some people have realized that these transactions are valuable, and they sort of use that to their own advantage. So they could actually selectively route transactions to particular miners who maybe pay them on the side or provide them with some sort of other benefit. And they might sort of share their transactions with that miner, but not any of the other miners, just because they're incentivized to do so. And this is actually kind of bad for the network because it increases a barrier. It creates this barrier of entry where if I want to stage a miner and I want to start contributing towards that infrastructure, then I won't be able to do so with as much. I won't be able to do so and sort of compete against those who do have these deals on the side that work in their favor. So because this sort of eliminates the competition that we should be seeing in a free market, it actually results in market centralization. And over time, if you wait long enough, this could lead to a monopoly where you have a single point of failure, which is a huge problem. So when I'm going to be sort of talking about a few other problems that proof of stake and proof of work blockchains have. But I just want to sort of highlight the fact that all of these blockchains differ from each other slightly. Some rely on volunteer work more than others, and some, rather than relying on volunteer work in order to sort of scale themselves up, then they actually introduce some form of closure into the blockchain too. So Bitcoin is a blockchain that is more reliant on volunteer work, and Ethereum is that blockchain that is more likely to introduce some form of closure. So all of these blockchains, whether they're proof of stake or proof of work, of course, I said that they're different. At a high level, they are facing the exact same problem, and Saito, it does resolve these. So the first problem I'm going to be focusing on is the Infura problem. And before I explain what the problem is, I should probably explain who Infura is in the first place. So Infura is a node provider for the Ethereum network. And they act as sort of that, they act as that middleman between you and the blockchain, the Ethereum blockchain. So they could take your transactions and maybe send them off to a miner where they'll eventually get posted on the blockchain. Now, they are a company. They're a centralized company. Therefore, they are a single point of failure. And at this moment, something that is rather alarming is the fact that they are a middleman for around 80 to 90% of Ethereum transactions. So even if I'm using MetaMask, for example, those transactions will be going through Infura unless I sort of modify a setting in MetaMask that'll have it go to a different node. But most people don't even really know of that possibility or that capability. So this actually sort of highlights that, or it shows us that Ethereum is actually way more centralized than we initially thought. And this has already proved to be an issue in the past multiple times. So one example of this proving to be an issue is in 2020, when there was a widespread Ethereum outage. And the reason why this outage occurred is because Infura was sort of running the wrong version of the Ethereum blockchain. So by running the wrong version, they weren't that basically paused the entire blockchain, and transactions weren't able to make it onto the chain. So we had a big outage in 2020, and there's also by using Infura for 80 to 90% of our transactions, we also introduced the possibility of gas prices being artificially inflated. I don't know if we have seen this in the past. I can't really prove it, but it could be theoretically possible for Infura to take some transactions that have higher gas fees and route those to miners and take those transactions with lower gas fees and decide to not share those on purpose. So then by ensuring that you have a blockchain, by ensuring you have a transaction that makes it to the blockchain, you have to pay a transaction fee that is higher than you should be paying. And so that is like market intervention. That's pretty bad. And since 80 to 90% of transactions go through Infura, they do hypothetically have this capability. So one of the core developers in the Ethereum Foundation has already sort of noted this as a problem. So Afri Shodan back in 2018 already said that if we don't stop relying on Infura, the vision of Ethereum has failed. But this is actually going to be, this is a really tough problem to tackle, because if we stopped using Infura, then who's going to be providing that infrastructure? So either we keep the same market closure and just use another Infura with a different company name, or we sort of rely on other people to do it for us, right? And we sort of introduce that notion of there being a free riding problem, like I already explained in the past. So Saito actually addresses this. And Saito does so by inventing a new consensus mechanism that is entirely different from the ones that are part of Bitcoin or Ethereum. So it's not proof of work, it's not proof of stake. It's actually, it was called proof of transaction at one point in time, but that was actually confusing a few users. So they settled on the idea of, or the name Saito consensus mechanism. And one thing I can promise you is that the concept that makes up the Saito consensus mechanism is much cooler than the name itself. So yeah, now this consensus mechanism is different from the proof of work and proof of stake ones, because it actually it pays for all of the work that's required to support this blockchain, rather than just adding blocks to the blockchain. So there's actually sort of three main different components that make up the Saito consensus mechanism. There's an element of mining, there's an element of staking, and there's also an element of routing. And I'm going to be covering routing first, because that is probably the most important aspect of the Saito consensus mechanism. So much like with other blockchains, Saito nodes also collect and validate transactions. And after validating transactions, they also share the transactions with each other. Now, instead of it hitting a miner, and you would hope that the transaction sort of hits a miner and then it'll eventually get posted onto a block that way, Saito allows nodes to post blocks on the blockchain if they satisfy a sort of routing work threshold, actually. So if we look at the diagram above, then we could see that a user is creating a transaction. First, it goes to node 1, who gets, first it goes to node 1, who gets 10 points for the transaction. Then it keeps halving as it goes from hop to hop. So node 2 gets 5, node 3 gets 2.5. And if there was a node 4, then we'd see 1.25, of course, right? So as it goes throughout the network, as it sort of gets shared more and more, the transaction gets less valuable in of itself. But the thing is, in order to post a block, you'd actually need to sort of meet a certain threshold of routing work points, I guess. So Saito, for example, could dictate that you are required to post 100 points, you are required to have 100 points worth of transaction fees or transaction points in order to post a block. So node 1 would have 10 points, which is a decent start. Node 2 would have 5, and they don't have to sort of start keep listening on new transactions that are coming in and add those to their own, like their pool of transactions. And once all of the points that they have sort of add up and go beyond that threshold, then they are capable of posting that block themselves. So as you can see here, nodes are actually compensated with the like in proportion to the amount of work or the amount of like data that they've shared amongst each other. So with this like routing mechanism, we've aligned the incentives so that the individual incentive is the same as the communal incentive. It is in my best interest to share data with the different nodes and participants in the Saito network, because it increases the likelihood that it will satisfy a block, that it will reach a block, or it'll get posted in a block. And if my transaction is included inside of a block, it doesn't matter if I'm in node 2, node 1, node 3, I will still make some money. The only difference is that those nodes who are closer to the user, those nodes who receive more routing points, they would be paid more, but I would still get paid. So everyone who contributed to the routing gets paid in this new mechanism. So as we could see with this mechanism, hoarding of transactions is actually less profitable. Yeah. Now, one other thing that I think is really cool with this mechanism is the fact that nodes actually want to service users. So I think that this is a really big problem within the Web3 space, because right now we don't really see any incentive for providing that infrastructure. And we also don't really see any incentive for developing the applications that sit on top of these blockchains either, right? And by using the Saito consensus mechanism, we could see that developers are actually incentivized to create Web3 applications, because if they build the application, they can dictate the cash flow themselves. So they can code the application to sort of send transactions to a particular node first before it reaches other nodes. So developers would actually be able to route transactions to their nodes, making them more money before that transaction is propagated and sort of shared amongst the other participants. Now, one other cool thing to note here is that using this consensus mechanism, the network is also sort of incentivized to optimize itself over time too. So node 1 might be directly dealing with the user. It might sort of hop through node 2 and get to node 3, but node 3 might say that, node 2 didn't really do anything of value. I could have just received the transaction from node 1 directly, and I would have made more money, because node 3 would actually be in node 2 scenario in that case, and they would be getting 5 points instead of 2.5, because they would have missed one of the halvings, right? So because this network is naturally incentivized to optimize itself over time, you could see increase in speed too, which I think is really interesting. So routing is probably where most of the magic happens within the Saito consensus mechanism. However, I already mentioned that there are two other components, and that is staking and mining. So although routing is really cool and it sort of incentivizes the sharing of transactions, one problem with it is that it doesn't really provide too much security in of itself. In order to provide security, you would have to introduce some other sort of mechanism that will play with this routing thing that I've covered. So if we were to just use routing as a mechanism itself, then we could see that nodes or attackers would actually be able to stage their own nodes, share the transactions with their own nodes, and post the blocks, and sort of use the profit from posting those blocks to keep generating more blocks, right? So they would actually be able to spam the network and sort of flood the network with unnecessary transactions, just by sort of using this circular attack. Now, the problem with proof of stake and proof of work blockchains is, like, we do see attacks similar to this, and it is entirely possible to rent like 51% of the hash power for the Bitcoin network and use the profits from hashing those blocks to further fund that renting of the infrastructure or renting of the hash power. So in order to sort of provide that layer of security that's necessary, Saito introduces this other mechanism called the golden ticket. And what the golden ticket does, it essentially makes it difficult for nodes to get paid. And a golden ticket problem has a golden ticket solution. And this golden ticket solution must be found through hash power. The golden ticket problem is a proof of work problem, just like Bitcoin, except it uses less power, and it shouldn't be melting any more polar ice caps than the Bitcoin than the Bitcoin problem does currently. Now, one thing to note is that you're not actually required to solve a golden ticket problem in order to post a block. What the golden ticket does is, if I post a block, then the golden ticket solution would be the problem to the previous block that resided in the blockchain before this recently posted block. And if there is the golden ticket solution for the previous block's golden ticket problem, then that means that everyone will get paid. So all of those routers and all of those, and also the miners who and also the miner who got the golden ticket problem, they would get a cut from that previous block. So 50% of the fees would actually go to the miner, and 50% of the fees would go towards those routers that collected those transactions and distributed them amongst each other. Now, if I were to post a block without it containing a golden ticket problem to the golden ticket solution to the previous golden ticket problem, then that would make it so that nobody gets paid, or at least the miners and the routers who participated in the creation of that previous block, they would not be paid. And as we can see, like with this, if we do have a continuous pattern where blocks are posted without the golden ticket problems, then fees are actually locked up within the network, and that's why Saito introduces this other mechanism for staking. So not only does it just prevent rampant deflation, because staking because using staking, the locks won't the funds won't be locked within the network. So if a golden ticket is if a block is generated without a golden ticket solution, then the stakers would actually get paid, as opposed to the routers and the miners that did that work. Yeah. Okay. So moving onwards to security, with Bitcoin and Ethereum, I already sort of briefly covered this attack in the previous slide, but it is entirely possible to do this circular attack where you flood the blockchain with unnecessary transactions. And you do that by just renting hash power or borrowing money so that you could stake more, which increases the likelihood that you can post a block. And if you do post a block, then you do get the entire reward, right? So I get that entire reward, and I could use that same money from the reward to just stake more or rent more hash power, and I could just do the same attack over and over again. And that gives me the ability to dictate which data I want to have in the blockchain and which data I don't want to have in the blockchain. Now, with Saito, we can see that attackers actually need to spend an obscene amount of money in order to attack the network. So remember I talked about that routing threshold. Now, if there's in periods of high traffic, then that routing threshold actually climbs over time. So when there's a lot of transactions or a lot of blocks that are being continuously posted, then routers will actually need to route more transactions amongst themselves to be able to post a block. And so attackers would actually need to spend more money in order to keep spamming blocks in the Saito blockchain. Also, the transaction fees or the rewards that we get for posting the blocks in the Saito blockchain are sort of distributed with the various other participants. Sometimes it goes to miners, sometimes it goes to stakers, and sometimes it goes to routers. And so that makes it actually impossible or very, very difficult. I don't even know if it is possible, but it makes it sort of it would make it difficult for the attacker to turn a profit. I don't think they would be able to turn a profit from performing this attack. Okay, so with this consensus mechanism that I've covered, we can see that there's actually no 51% attack. There's no 51% of hash power that you could rent, or staking 51% of coins or anything like that. Routing work or your the ability to post a block is solely dependent on how many transactions you have shared with others in an open manner. And we can see that attackers lose money if they attack the blockchain, and honest participants who do like distribute transactions with each other and provide things of real value, they will turn a profit. Now, one other cool thing that I wanted to note here is that it's possible for the network to, not only is the network less susceptible to attacks because of the climbing thresholds and all that, the network is also capable of defending itself too. So if we do have blocks continuously posted, and even if the attacker were to have all of the routing and the mining nodes, then other participants in the network would be able to post blocks on top of theirs without golden ticket solutions, which would make the money go to the stakers rather than back to the routing nodes and the miners. Okay, so that's kind of everything with the Infura problem. If we move on to the next problem, I wanted to cover the rent problem. And with a typical blockchain like Ethereum or Bitcoin, we could see that data is actually stored for all eternity, right? With data on these blockchains, there's actually a one-time payment that you pay one time. It's a large sum, and then that data should be residing in the blockchain for all eternity. But unfortunately, the storing of information is a continuous cost. It's not a one-time payment. Like if I were to go on Google Cloud and post a document or some kind of file on there, then we could see that it's actually a monthly fee, and it wouldn't be a one-time payment. And that's because it would cost more to provide that service over a longer duration of time rather than a short one, right? So it should be sort of done on like a subscription-based model almost, as opposed to that one-time payment. So now, because of this problem where data has a continuous cost in order to store it, miners and nodes actually, they've actually been dropping some of the old blocks off of their copies of the blockchain. And they do so in order to reduce their operational costs. So if my copy of the ledger is smaller in size, then I have to spend less money on the hard drives necessary in order to store this entire blockchain. And that sort of introduced this new reliance on other different types of nodes called archival nodes. And archival nodes are nodes that do store an entire copy of the entire ledger and all of the transactions that have happened in that ledger throughout all of history. So Etherscan is one service that is highly dependent on these archival nodes, because if we go on Etherscan, we could see all of the transactions that have happened in all of Ethereum's past. Now, just within the last 2 years, because these blockchains are growing and only growing, you don't delete anything, we could see that within 2 years, these blockchains, the Ethereum blockchain, has grown exponentially. So literally just 2 years ago, an archival node was required to store 2 terabytes worth of information. And now an archival node is required to store about 10 terabytes of information. And this only leads me to think, what's it going to look like in 10 years or 20 years? How much size or how much hard drive space is going to be required to store the entire blockchain then? So this is very similar to the tragedy of the commons economic problem. And we can see that miners are incentivized to store more data on the blockchain because they get paid more upfront. But however, those costs of storing the data are actually passed on to the other participants in the network. So miners make a lot of money because they post a huge amount of data, and nobody else makes any sort of money later on in the future. And that sort of leads to this blockchain bloat. Now, Saito takes a very different approach to this problem. And Saito does so by introducing a blockchain that is actually circular. So rather than it just being a single linear chain of blocks that are chained together, it's really a chain of blocks that sort of compose a circle. So first things first, Saito is a UTXO-based blockchain, meaning it's just like Bitcoin, where every transaction has an output. So if I were to send Bitcoin to a friend of mine, then we could see that one of those transaction outputs would be directed towards my friend. And one of those transaction outputs, the remainder of the Bitcoin that I have, would be directed back to myself. And transactions also have inputs, and inputs are really just pointers to sets of UTXO. So now with the Saito blockchain, since it is circular, the size of the blockchain stays constant. So it's up to the community to determine how large of a blockchain they really want. It could be 1 terabyte, 2 terabytes, 10 terabytes. Either way, it stays the same and it doesn't grow uncontrollably. And the way that this is accomplished is by introducing this new mechanism called automatic transaction rebroadcasting. And users can actually specify on their transactions whether they want to have their transactions automatically rebroadcasted. And if a transaction is automatically rebroadcasted, then the transaction and the data that composes the transaction will be sort of automatically brought over to the front of the chain again, and it'll go through another cycle. Now, if the user decides not to specify, not to flag a transaction as being automatically rebroadcasted, then that transaction will just fall off the chain. And this is sort of, remember at the very beginning of the presentation, I said that normally data wouldn't be deleted off of the blockchain. This is how Saito sort of addresses that. So users can actually specify which data they don't want to have automatically rebroadcasted. And as a result, over time, that data would be deleted too. Now, in order for a transaction to be rebroadcasted, it actually needs to, similar to new incoming transactions, it also has to pay another transaction fee. So the UTXO that was from that previous transaction is really just spent again in order to be posted on the blockchain. And these transactions that are being rebroadcasted actually compete with some of those new incoming transactions for spots on the blocks. And typically, these transactions that are being rebroadcasted are actually twice as expensive as those new ones that are being put on the blockchain. So this is some form of rent, because those transactions that have been on the blockchain longer pay more rent than those ones that haven't been on the blockchain for as long. And now, one other thing that's neat about this is that nodes are actually, because the transactions that are being rebroadcasted at the tail end of the blockchain have more fees associated with them, they're more lucrative to include in your blocks as opposed to new ones. We could see that nodes, or those people who are creating the blocks, are actually incentivized to store the entire blockchain. They're incentivized to do so just so they could see what those oldest transactions look like, so they could rebroadcast those themselves. And one other very powerful, cool thing that I think this solution introduces is a new mechanism that is used to share genuine copies of the blockchain with nodes that are entering the network. So now, like with Bitcoin or with Ethereum, if I want to join the network, I don't have to trust in some other node to provide me a valid copy of the blockchain. All I have to do is listen to the Saito blockchain go through one full cycle. And once I listen to it go through one full cycle, then I have a valid copy of the blockchain, and I can start participating in the network and the provisioning of that infrastructure myself. Okay, so those are kind of that's kind of the consensus mechanism that Saito introduces at a high level. And as we can see, Saito actually solves this very infamous scalability trilemma that was coined by Vitalik Buterin a while ago. So Saito is able to it's able to scale to a commercial level, yet it doesn't neglect security or openness. You could actually have all three with Saito. And with Ethereum, you would have to choose 2 out of those 3. And Saito was able to do this by aligning the personal and the communal incentives. So now what is good for the greater good is actually best for myself too. And Saito did this by sort of assigning a price to every sort of activity that's required to keep this blockchain operational. And once you sort of see how Saito addresses these issues, and once you understand the issues that are at play with these other blockchains, then it's very difficult to unsee it. And that's why I think that the Saito blockchain is something that is something that's like a red pill in the matrix, where once you know the truth, you can't forget the truth, and it'll just stay with you forever. So in terms of Ethereum, I don't really think it's been designed to work in a commercial sense. I kind of view it as a blockchain that's more of a beta to demonstrate the fact that smart contracts are hypothetically possible. Yet they have continued to go with this like blockchain with these incentives that aren't really, optimized or aren't optimal. And as a result of that, they have to go through this technical rat race where they have to keep on they have to keep on writing complex code and make trade-offs to keep the Ethereum network from sort of imploding or to keep it usable, essentially. Now, in terms of Saito's place within all of this, I think that Saito can really play nicely. So I don't think it has to replace Ethereum altogether, and not even Infura for that matter. I kind of see Saito as being a potential business model that that Infura could utilize that would actually be healthier for the Ethereum network too, just because you don't introduce that economic that market closure that I just discussed in the past. So in terms of use cases for the Saito network, essentially at a high level, what Saito is meant to be is it's supposed to be a blockchain or a network that's it's supposed to be as loud as possible. And the reason it's so loud is so that it can guard and protect openness at all costs. Now, I can definitely see Saito being used as like a middleman. So acting as that network layer where the sharing of transactions is done for many blockchains. It could be that networking layer or for Ethereum, for Polkadot, for Bitcoin, and for any of those blockchains that have incentives that are very much geared towards the appending of blocks as opposed to any other of those other activities. Now, Saito doesn't also have to be a middleman in of itself. It has a lot of use cases within the Web3 and Web2 realm. First of all, smart contracts are also possible to build on top of the Saito network themselves. So just like you do with Ethereum now, it would be possible to build smart contracts and have those smart contracts sit on top of the Saito network now as well. Now, we don't have this functionality yet, and I haven't seen it in the roadmap yet either, but it is a possibility, and I think that could be huge, and it would change the business model behind providing some of these Web3 applications. So going beyond that, in the Web3 realm, if we're talking about like a decentralized Facebook or a decentralized Twitter, Saito could also be used as a useful layer to help you identify service providers. So like I said, Saito is meant to be as loud as possible. So you could sort of broadcast your need for a Facebook node or broadcast your need for a Twitter node who will be able to provide that decentralized Twitter service for you. Now, one other neat use case that I see Saito performing or providing is the possibility of performing a Diffie-Hellman key exchange over the blockchain. I know that sounds like a whole bunch of technical jargon, but it's actually huge because if you log into a banking website, for example, or even Facebook for that matter, if you see HTTPS in that green lock at the top corner, then essentially what that means is that you've established some safe form of communication between you and that website or that endpoint that you're communicating with. So if that data or that channel is encrypted, then none of those people who are sort of, none of those people that the transaction is going through in order to reach that endpoint can actually decipher what you're saying. So if I'm logging in to my banking website and I have to provide a username and a password or a PIN, then none of that would be sent in plain text, and no one would be able to sniff that out and act like and use those same passwords and usernames in an attack in the future because of it being encrypted. They would see it as a whole bunch of encrypted crap that they don't understand, and it would be understandable for me and that endpoint that I'm communicating with. Now, the Diffie-Hellman key exchange is necessary in order to establish this encryption. And so I definitely see Saito being useful in that sense. And one other thing that I think is really cool is that not only does it help you establish encryption itself, I can definitely see it act as something that can help us with authentication too. So now, because users would have their own private keys and their own public addresses within the Saito blockchain, then they might not even have to provide a username and a password themselves. As long as they have their private key, then they could sort of sign their messages using their private key, and the endpoint that they're communicating with would already know that they are genuinely interacting with that person. So it could augment username or password authentication, or it could actually replace it altogether, which I think is a huge possibility. So at this given moment, there is a functional arcade that's also built on top of the Saito network. So you could play a bunch of games, from poker to, I think there's a cool one called Red Emporium, and I think you could play one that's just like Pandemic. Now, the cool thing is that with a lot of these games, they're actually using cryptography to do a bunch of things in a fair manner, such as shuffling cards for a poker game or rolling dice. And when they are actually building this, I believe that some other people told them that this was impossible to do, yet they managed to solve the impossible, which I think is kind of interesting. Now, with that being said, Saito, I think it's very important to mention that Saito is not a gaming blockchain. I know that they have an arcade that's built on top of the network, and they have been partnered with the Elrond network, but Saito is not just for gaming. It is actually a blockchain that is meant for much more than just that. It just happened to find a space within the gaming space first. Now, in terms of the token itself, why would you actually want to own it? What actually drives the buying and the selling of these tokens in the first place? So Saito has an interesting use case for this, and it's very much geared towards Web3, where users own their data, and the power is ultimately given to the user as opposed to centralized parties or companies like Facebook. So in order to, so advertisers or network operators could actually pay users Saito in order to do things such as view advertisements, or maybe fill surveys for them, or even just selling some of their personal information, right? And once I do that, then once I sell my personal information to an advertiser, for example, they'll benefit in the sense that they can probably do a little bit more targeted advertisement. And also I benefit because I get Saito tokens that I could use to use these services that are built on top of the Saito network. So I would use those same Saito tokens and give them off to the infrastructure, which keeps the Saito network running. And then in turn, the advertisers would buy those tokens back from the infrastructure layer and sell it back to the users for some of their for performing some of those activities, like viewing those ads, like I said. So at this given moment, the state of the Saito network is actually at a very early stage. So they do have a testnet running at this given moment, and it's built on top of a JavaScript client. And they do have some arcade games that are built on top of this network too. But that being said, at this, like right now, they are working towards a mainnet. And what that entails is it's actually composing of several different parts. And one of those parts is a Rust client as opposed to a JavaScript client. I believe Rust is written in a language similar to JavaScript, or if not, if it might even be JavaScript in of itself. But Rust is different in the sense that it can allow these nodes to run the Saito code or run the Saito software on multiple processors as opposed to one, which should really increase performance when providing an infrastructure. So one other thing that Saito was working on is token persistence. So there's a lot of complexity that goes along with this automatic transaction rebroadcasting and the circular blockchain. So at this given moment with the testnet, Saito was not able to guarantee that tokens that belong to you within that blockchain are going to stay there. So right now, Saito is just an ERC20 token, and you keep your Saito on the Ethereum blockchain. But once they have a mainnet, then you will be able to move your funds onto the Saito network through some sort of bridge. Now, there also isn't a staking mechanism built yet, so they do have some of that math figured out. They do know what it's going to look like, but that's going to have to be built as part of the mainnet as well. Now, with all of this being said, there's a huge need for developers for the Saito network, because once we have a bunch of cool applications built on top of the Saito network, that's going to attract many more users. Okay, so now moving on to the conclusion, Saito was ultimately a blockchain that can allow users to run blockchain apps within their browsers. So if I'm just a user and I'm not running any sort of node itself, I don't have to keep a copy of the blockchain. All I have to do is have like a private key, public key, some high level information that's required of me to create transactions. Yet nodes are more than happy to provide to be my endpoint for the Saito network because they are paid to do so. They want my requests because they make money off of them. And now with this whole Saito consensus mechanism, we could see that it is entirely self-supporting, and it's an open network layer for the Web3 world. And ultimately, this openness is going to prevent any sort of monopolization from occurring in the future, which I think is neat. So I think that Saito has the ability to have a huge, profound impact on the blockchain space. And I think it's also very revolutionary. So we're on the cusp of something that could potentially be a backbone to an entirely new internet. And with this entire mechanism, just the way everything sort of seems to work together, I think it's a form of art. So yeah, I'm very interested to see how the rest of everything is going to play out for the Saito network. One thing to call out is that Saito is a fix to a problem. And in order to really understand the true value behind Saito, then you have to understand the problem in of itself. And that results in a big communication challenge. Now, another big call out that I wanted to note was that the community behind Saito, all of the Telegram chats and everything, everyone is amazing. They're very supporting of each other. And I've learned a lot from interacting with some of those people. And I've also learned a lot by interacting with David and Richard. So that's everything I have to say about Saito. I hope I managed to teach some of you something about this blockchain. I'll be providing some links for the Saito website and also a link to the Telegram chat if you want to join in there and ask some of your own questions too. So thank you very much.